Okay, so you want to know what's really happening now in space innovation, especially, how the big ideas are actually getting funded.
Yeah.
You're definitely in the right place. Buckle up, because we are diving straight into some recent investments, the ones fueling the next wave of space-based internet tech.
Hmm.
Think of this as your quick guide, your shortcut to understanding who the key players are and the really innovative things they're trying.
Exactly. Yeah, we've pulled together some recent funding news, company details, basically looking at 5 pretty fascinating startups.
Okay.
Yeah, and each one has a really unique angle on connectivity, on infrastructure, stuff beyond Earth.
Uh-huh.
Our goal today really is to get past just the dollar figures. We want to understand the tech leaps they're making,
Yeah.
and what all this investment actually signals about the future of, well, how we connect and use space.
Okay, let's unpack this then. 5 companies pushing the boundaries. We're going to start with Sophia Space,
Okay.
then look at Aetherflux, Northwood Space, Taara, and wrap up with Pixxel. And I think what you'll see pretty quick is that space internet,
Yeah.
well, it
Yeah.
means a lot more now than just getting Wi-Fi from orbit.
Oh, absolutely. It's way more nuanced. Each one of these companies is tackling a specific piece of the puzzle. You've got data processing in orbit, new ways to beam power, different ways to send data.
Right. So let's start with Sophia Space. They're in Pasadena, just got $3.5 million pre-seed funding.
Mm-hmm. Pre-seed. Yeah.
What really jumped out at me was their description. Modular, solar-powered, AI-optimized orbital data centers. I mean, that sounds seriously advanced. What's the core idea?
Well, the key thing is edge computing, but in space. They have this Tiley platform.
Tiley.
Yeah. And think about just how much data satellites are collecting constantly. It's enormous.
Right.
So instead of beaming all of that down to Earth to process it, Sophia Space wants to analyze a lot of it right there in orbit.
Ah, okay.
And that drastically cuts down latency, the delay, which is super important for anything needing real-time info.
So processing it up there speeds things up.
Exactly. It's kind of a potential shift away from needing these massive data centers just on Earth. Could change things for data sovereignty, speed of insights.
Okay, and this is where it gets cool.
Yeah.
They talk about using it for geospatial intelligence, disaster monitoring.
Mm.
So, like, imagine a hurricane or something, getting almost instant analysis of satellite images. That low latency you mentioned, that's suddenly a massive deal.
It's a total game changer for response times, yeah. And having Dr. Leon Alcali involved, he's a former NASA JPL fellow, that adds real technical credibility.
Definitely.
So this funding, even though it's pre-seed, it's a big nod to a really forward-thinking way of handling space data. Now, let's maybe pivot to Aetherflux. They've got a much bigger round, different goal entirely.
Aetherflux, yeah, I saw that. A huge $50 million Series A.
Mm-hmm.
And the founder, Baiju Bhatt from Robinhood.
That's the one. Plus, you've got Breakthrough Energy Ventures, Jared Leto, some big names investing.
Wow, okay. And their mission is space-based solar power. How on earth does that work?
Well, on Earth is maybe the wrong phrase. It's incredibly ambitious. Think about the global need for clean energy, right?
Sure.
They want to put satellites up that collect solar energy and it's space. Sunlight is constant, no clouds, no night.
Right, 2047 sunshine.
Exactly. Then they transmit that energy wirelessly down to Earth using infrared lasers.
Whoa, lasers from space, beaming power.
That's the concept. I mean, the engineering challenge is immense, obviously, but the payoff, a potentially global, reliable, clean energy source, it's huge if they can pull it off.
It really is. And they're targeting remote places, military ops, areas without good infrastructure. And that makes total sense. Power where it's hard to get.
Precisely.
But what are the big hurdles? I mean, lasers through the atmosphere, is that safe, efficient, and just the scale of building that in orbit?
Yeah, those are the key questions. Atmospheric transmission efficiency, safety, definitely big technical nuts to crack. And the cost, yeah. Deploying and maintaining it won't be cheap. But, $50 million Series A says some major players think it's solvable, that the long-term potential is worth the risk. It's a big vision.
For sure.
Okay, now let's switch gears a bit to Northwood Space. They're tackling a different, but just as vital, piece of the puzzle.
Northwood Space.
Yeah.
The one with Bridget Mendler as CEO.
Yeah.
That got a lot of attention.
It certainly did. But beyond the headlines, they raised a solid $30 million Series A for something very practical. Portable, high-powered ground antennas.
Ground antennas. Okay, why is that so important?
Ah.
Seems less flashy than space lasers.
Huh. Maybe less flashy, but absolutely critical. I mean, all this amazing stuff in orbit needs to talk to the ground effectively, right?
True.
Northwood says their antennas are way more effective than the usual dishes. And think about setting up current ground stations. It's slow, it's expensive, they're fixed in place.
Right, big installations.
So the portable part is key. It means you can set up Earth-to-space communication links much faster, much more cheaply.
I see. So speed and cost.
Exactly. And with more and more satellites going up, more data coming down, maybe even power, like with Aetherflux, you absolutely need better, more flexible ground systems.
That makes sense. The plumbing needs to keep up with the faucet.
That's a good way to put it. This funding will help them get those antennas developed and out there. Okay, next up, Taara. Interesting backstory with them.
Yeah, Taara spun out of Alphabet's X Lab, the moonshot factory.
Yeah.
That definitely signals innovation pedigree.
Right.
Their funding amount wasn't disclosed, but Series X Capital led it, and Alphabet's still involved. Their thing is also lasers, but for data transmission. How's that different?
Well, what's interesting is Taara isn't really focused on space-to-ground internet, not like Starlink or others.
Right.
Their laser tech is more of a high-speed wireless alternative to laying fiber optic cables on Earth. Think point-to-point links, very fast ones.
Okay, so ground-based laser links.
Yeah.
Got it. And the speeds are pretty wild.
Yeah.
Up to 20 GBps, over 20 kilometers.
Yeah, really impressive performance. And they're already operating in like 12 countries.
Mm-hmm.
It seems perfect for connecting places where digging trenches for fiber is just too hard or costs too much, like rural areas, underserved communities.
So it's tackling connectivity, but more the last-mile terrestrial challenge.
Exactly. Bridging those gaps in existing networks. It's a vital piece. And Alphabet staying invested shows they really believe in this laser tech for solving those ground-level connection problems.
Makes sense. Okay, last one, Pixxel.
Pixxel, right. Dual HQs, India and the U.S.
And they've raised quite a bit overall, haven't they? Like $95 million total now after a $24 million Series B extension, with Google Lightspeed involved.
Yeah, significant backing. And their niche is different again. Earth observation using a constellation of hyperspectral imaging satellites.
Hyperspectral. Okay, what does that actually mean compared to like a regular satellite photo?
Okay, so think about regular satellite images or even your phone camera. It basically sees red, green, and blue light, right? A few broad color bands. Hyperspectral imaging captures data across hundreds of really narrow, specific bands of light, way beyond what our eyes see.
Hundreds.
Hundreds. So it's like getting hundreds of images at once, each showing a very precise sliver of the spectrum. This lets you see the unique signatures of different materials or conditions, things totally invisible in a normal photo.
Like what kind of things? They mention crop health, pollution.
Yeah.
Stuff you can't normally see from space.
Exactly that. You could potentially spot crop diseases way earlier than visually, see exactly how healthy plants are across huge areas, optimize water use.
Wow. For farming, that's huge.
Or track pollution, not just that it's there, but maybe even what kind of pollutant it is by its spectral fingerprint. The level of detail is incredible.
Okay, that's genuinely powerful data.
It really is. The potential for agriculture, environment, energy, monitoring disasters.
Yeah.
It's massive. And that continued funding, Series B level, shows investors see huge value in that super detailed Earth data.
So stepping back and looking at all five, Sophia, Aetherflux, Northwood, Taara, Pixxel, it's really clear that space internet isn't just one thing anymore. It's this whole diverse ecosystem developing.
That's the perfect word for it. Ecosystem. These funding rounds really highlight just how many different ways companies are approaching space. It's way beyond just satellite broadband now.
Yeah.
You've got data processing in space, power from space, better ground links, different ways to move data on Earth using space-related tech, and this is an incredibly detailed way of seeing the Earth from space.
And the funding stages are all over the map too, right? Pre-seed for Sophia, Series A for Aetherflux, and Northwood Series B for Pixxel. It suggests some ideas are brand new, others are starting to scale up.
Precisely. It shows a maturing field, maybe. You have early bets and follow-on investments. And the investors themselves, VCs, strategic partners like Alphabet or Google, even individuals, it signals really broad interest.
Yeah, everyone wants a piece of the space pie, seems like.
Well, the potential impacts are huge, aren't they? Taara hits rural connectivity directly. Pixxel is huge for environmental monitoring. Aetherflux could change energy. Sophia changes data itself. It touches so many sectors.
Absolutely. So, to sum it up, we've looked at 5 really interesting companies, all recently funded, each tackling a unique piece of using space for connectivity, power, infrastructure, observation. It's clear things are moving fast and in lots of different directions.
Yeah, definitely expanding beyond just faster internet speeds. This is just a snapshot, of course. The field is evolving incredibly quickly.
For sure. Okay, so here's something to maybe chew on as we wrap up. We talked about internet, data, power. But think more broadly. How might all these different space technologies, orbital data centers, space lasers, hyperspectral eyes in the sky, how might they fundamentally change whole industries? Or even just how we understand our own planet and, well, our place in space over the next few years? What overlooked opportunities might pop up because of these advances, maybe in your field, your business? Something to think about.
Definitely food for thought.
Mull that over, and we got you next time for another deep dive.